Let's take a look at this question. In a mid-sized company, the distribution of the number of phone calls answered each day by each of the 12 receptionists is bell-shaped. It has a mean of 40 and a standard deviation of 4. Draw the associated normal distribution curve and label the axis appropriately. Okay, so the associated normal distribution curve. I draw my distribution curves starting with a horizontal line and then the bell curve above that. And that gives me better looks than trying to do the bell curve and then the horizontal line. Right down the middle is the mean. In this case, the mean is 40. Next up, a standard deviation. Now you can see my bell curve isn't perfectly shaped. It should be symmetric, and it does not look symmetric. So a way to estimate where the standard deviation number is the line, the standard deviation, should go up about 5/8 of the way up the mean. So here and here. And they should be equally spaced, and that's why it's important to label the axis. Because if your bell curve isn't perfect and you label it, it should still represent an accurate depiction of the situation. So 40 is the mean. The standard deviation is 4. So if I go 4 to the right of 40, I get to 44. And 4 to the left of 40, 40 minus 4 is 36. And now with that spacing that's been created, and it's not the same, and it should be, so kind of estimate about that same distance 2 more times, and we have the 3 standard deviations to the right and the 3 standard deviations to the left of the mean. We just need to continue to do the standard deviation of 4. So 40 plus 4 is 44, plus 4 is 48, plus 4 is 52, and 36. 40 minus 4 is 36, minus 4 is 32, minus 4 is 28. And then let's label this as number of phone calls. So, phone calls. Excellent. And the height is always frequency. That's just the default. So the horizontal axis is the most important one to graph and to label. Okay, so go ahead and pause the video while you work on the problem on the right. What you should have, again, you have your bell curve, the mean, 8,000, 1 standard deviation to the right, 8880, another standard deviation to the right, 9760, and the 3rd standard deviation to the right, 10640. And going to the left, we have 7120, 6240, and the 3rd one, 5360. Similarly, for the problem below, again, you have the normal distribution, bell curve, the mean, 15.8, 1, 2, 3, 1, 2, 3. From left to right, we have 9.5, 11.6, 13.7, 15.8, 17.9, 20, and 22.1. Now let me show you a technique to verify these numbers quickly with your calculator. So pulling up a calculator, most people have an answer button on their calculator. In this case, it's right down the bottom right. So turning on your calculator, if you type in the mean, like the 8,000, and hit enter, and then 880 is the standard deviation. If I add 880 and hit enter, that'll get me the 8880. If I hit enter a second time and a third time, I will generate the 3 numbers to the right of the mean. And then going back to the mean, enter, and subtract the standard deviation once, twice, 3 times. that gives you the numbers to the left. So again, on the bottom, 15.8 is the mean. The standard deviation is 2.1 plus 2.1 once, twice, 3 times. There's the numbers to the right. And go back to the mean and subtract the standard deviation once, twice, 3 times. This gives you a very secure and fast way to generate the numbers to the left and the right on the normal distribution curve. All right, I hope this helps.